Alright, welcome back. I hope you had a good weekend. Okay? So last class we started talking about consumer behavior, and we talked about the concepts of utility, marginal utility, and how to maximize the total satisfaction, how individual consumers distribute his or her income to different goods and services, right, to maximize the total satisfaction and so on, right? And we had that rule, right? Marginal utility of A divided by price of A must be equal to marginal utility of B divided by price of B, right? And so on, right? So this is the rule for the utility maximization, okay? So let's say right now they are not equal. Let's say this is pizza, this is Coke, right? And let's say right now it's 3, which is less than 6, right? So what's the story here? Can someone tell me what those numbers mean? What's 3 and what's 6? Okay, go ahead. Marginal utility of pizza. First of all, what is the marginal concept of marginal utility? What do we mean by marginal utility?
It's utility that one gains at the last purchase.
Okay. Yeah, so marginal utility is the amount of satisfaction we receive from consuming one additional unit, right? One additional unit of this good, right? So the marginal utility is the amount of satisfaction you receive from one last unit or one additional unit, right? Are you saying that's 3? So the last slice of pizza you ate, you received 3 util? Is that correct? Or what do you think? Huh? No. I'm asking, what is 3? You said that's the marginal utility you get from pizza, one slice of pizza. Is this correct? Anybody else? He missed just one thing, right? That's the marginal utility you receive from one last slice of pizza divided by price of pizza, right? Right? You see it? Okay. So what is it? So in other words, what do you get? I mean, if you divide it by the price, that's the most important concept, you know. You have to make this equal to this. We're not talking about marginal utility of A equals marginal utility of B. Marginal utility of A divided by price of A should equal to marginal utility of B divided by price of B, right? So what are we requiring here? Eh? Exactly what must be equal between A and B?
Units.
Units of what? Units of satisfaction? Per dollar. Yes, per dollar. That's the most important thing, right? So right now, if you are maximizing your total satisfaction, $1 you spend on pizza should give you equal amount of satisfaction to $1, the satisfaction you receive from $1 you spend on Coke, right? Make sure you understand that, right? So if they are not equal like this, the story is right now if you spend $1 on pizza, you receive only 3 utils. But if you spend the same $1 on Coke, right, you will receive 6 utils. Then there is a way to improve the situation. In other words, there's a way to increase your total satisfaction. How?
Spend less money on B and more money on A.
What do you think?
Vice versa.
Yeah, the other way around, right? Because if you spend $1 on pizza, you only receive 3 utils, right? But if you spend the same dollar on Coke, you receive 6 utils, right? So spend less on pizza and more on Coke, right? So shift $1 from pizza to Coke, right? Then you lose 3 utils because you're consuming 1 less dollar worth of pizza, right? So you're not going to receive these 3 utils, but you're going to receive 6 utils when you spend that $1 here. So what's going to happen to your total satisfaction? By $3. You understand? Make sure you understand that clearly. It's a pretty simple idea, right? If they're not equal, then there's a way to increase the total satisfaction by shifting your money this way or that way, right? Right? Okay. All right. So if you do that, right now, if you spend a little less on pizza and a little more on Coke, right? What's going to happen to the marginal utility of pizza and Coke? If you consume a little bit less pizza, right? What's going to happen to the marginal utility of pizza? It will increase, right? What do we call that? Because of what? Law. Last class we learned the law of what? Diminishing marginal utility, right? Diminishing marginal utility, right? What it says is if you consume more and more of the same thing, right, you're going to get less and less satisfaction from each additional unit. We talked about it, right? Having ice cream, 1 scoop, 2 scoops, 3 scoops, right? The first scoop may taste, heavenly, fantastic, extremely satisfying, right? But after 1 scoop, if you have another scoop, well, it may be pretty good still, right? But not as good as the first one, right? And so on, right? So eventually you're going to stop. Yeah? Okay? So that's the idea, right? So if you shift $1 or money from pizza to Coke, then this will slowly increase because you're going to consume less and less pizza, right? But if you consume more and more Coke, this is going to decrease. Marginal utility of Coke will decrease, right? Which means this will slowly increase, this will slowly decrease, and eventually they may become equal. Say maybe 4.5, 4.5, whatever, right? Then, what do you know? If that happens, what happens? That's right. That's the maximum utility, maximum total utility you have received from 2 goods, right? In other words, at that point, you are optimizing your consumption, right? Right. So, yeah, I think we did this at the end of last class, right? So based on this idea, we could actually derive an individual demand curve. In chapter 3, we learned the law of demand, right? And law of demand simply says when the price of X goes down, quantity demanded for X will increase, right? There's an inverse relationship, right? So if the price goes down from P0 to P1, right, then the quantity demanded will increase from Q0 to Q1, right? So we have this downward sloping demand curve. That's the law of demand, right? And about why or how it happens, right? We talked about, briefly the substitution effect and income effect. Okay, right? Yeah, but here we can actually derive the downward sloping demand curve exactly, right? For example, let's say initially we were maximizing utility, right? So right now, marginal utility for pizza was 10. The price of pizza is 2, right? And the marginal utility of Coke was 5, and the price of Coke was 1, right? Then we had what? Make the marginal utility per dollar of each item equal on both sides, right? Marginal utility per dollar is 5 here, and here also it is 5. So whether you spend $1 on pizza or Coke, you receive the same amount of satisfaction, which means there is nothing you can do to improve the situation, right? Whether you shift $1 from pizza to Coke, if you do that, then you lose 5 utils on the pizza side, and you gain 5 utils on Coke side, so your total satisfaction will not change, right? If you shift $1 the other way around, if you spend $1 less on Coke and more on pizza, the same thing happens, right? So there is no way you can improve. In other words, you are currently at the peak. You are currently maximizing the total satisfaction, right? All right. And then let's say suddenly price changes. This week, say Pizza Hut is having a sale, right? And instead of $2 per slice, they're charging $1.50 per slice, right? Then what's going to happen? Suddenly, the equilibrium broke. In other words, you're not maximizing anymore because 10 divided by 150 is something like almost 7 units, right? So that means right now, if you spend $1 on pizza, you receive about 7 units of satisfaction, almost, right? But if you spend $1 on Coke, you still receive 5 units of satisfaction. What are you going to do? Is there any way you can increase your total satisfaction?
Buy more pizza. Less Coke.
Right, because $1 you spend on pizza will give you more satisfaction than $1 you receive spend on Coke, right? So if you reduce the consumption of Coke, or if you drink one less cup of Coke, and use that $1 to purchase more pizza, right? Then your total satisfaction will increase. Okay? Good. So what we just said was, okay, initially $2 was, the price was $2. Now it is $1.50 for pizza. Okay? And as a result of this decline in price, consumers will have more pizza, right? Why do they do that? In order to maximize their total satisfaction, right? In order to maximize their total utility, they will increase the consumption of pizza, right? So the demand curve is downward sloping, right? So that explains the law of demand, right? In other words, the reason why we see the law of demand is people are trying to maximize their total satisfaction, right? And they're trying to come up with the optimal consumption combination between A and B or if you have, well, in reality, you consume a lot more than 2 different goods, right? You have what? Every month when you receive your salary, right? On how many different goods and services do you spend your money on, right? Well, of course, well, food, well, let's say, even in the category of food, you can think of so many different types of food, right? Starting from pizza or ramen or what, kimchi jjigae or whatever, right? So, food, utility, right? Housing, apartment rent, right? And entertainment, education, or credit card bill, all kinds of things, right? So what is the way to maximize your total satisfaction, or in other words, what is the consumption combination that will give you the largest happiness, largest amount of happiness or most happiness? Well, you have to make let's say xn over pn, right? You have to make all this equal, okay? And again, nobody does that exactly, right? Nobody, there's no way you can actually calculate all these amounts. Oh, I'm sorry, this. So instead of x1, we're talking about marginal utility from 1, marginal utility from x2, and so on, right? Marginal utility to marginal utility. Okay? Well, first of all, there's no way we can actually measure the amount of satisfaction, right? So, this is simply an idea, hypothetical equation, right? There is no way you can actually calculate it, right? But in everybody's mind, you do that, right? Because you consider, well, how much, movies, how many movies will I see this weekend, right? And right now, well, if I have $10 for my entertainment budget for the weekend, right? Am I going to watch a movie, or am I going to drink a couple of beers, or whatever, right? So when you make that decision, you're going to compare the amount of satisfaction you receive, right, to the price, right, the cost you have to, pay, right? Okay, so that's the idea. All right, we talked about this already, okay? And this, what we talked about so far, is the individual demand curve, right? What's going on in one person's mind, right? How each person comes to the consumption decision, right? And as a result, we've found out that for each person, we can imagine this downward sloping demand curve, right? Now, what about the market demand, right? Market demand is nothing but a horizontal summation of individual demand curves, right? So we can simply just add them up, right? Add the one person, my demand curve, to David's demand curve, to Laura's demand curve, right? And so on, right? So here exactly, well, according to my demand curve, if the price was $1.50, I would consume 4 slices of pizza, right? But David, if the price was $1.50 per slice, he would consume 6 slices of pizza, right? What makes this difference? In other words, what causes this difference in the quantity demanded for each person? What are the factors? Taste, okay? Each person has different taste or preference, right? So, yeah, David probably, well, loves pizza more than I do, right? So at the same price, he consumes more slices, or maybe he has a little more larger stomach, or whatever, right? And income, right? Income also matters, right? No matter how much you like to consume something, if you don't have enough money, then you won't be able to consume, right, as much as you like, right? So, at the same price, $1.50, I demand 4 slices, David demands 6 slices, and Lori demands 5 slices, right? Okay. So, total demand or total quantity demanded in this market or in this economy, right, is 4 plus 6 plus 5, that's 11 slices, 15 slices at $1.50, right? And of course, at different prices, you can simply add all of them, right? So that's what I mean by horizontal summation. You can just simply add them horizontally, and you can come up with the market demand curve. Okay? Simple idea. Any question? All right, so the textbook gives this example as an example of given good. Given good is a very special case. So let me just summarize. We have talked about the substitution effect and income effect. Think about the effect of, say, price of X going down and price of X increasing, right? What's going to happen to the quantity demanded for X, right? Well, it depends on whether the X is a normal good or inferior good. Okay. And there are two forces in that's going to affect the quantity demanded. Right? First one is substitution effect. And the other is income effect. Okay. Substitution effect is when the price of something changes, say price of X decreases, right? Then we can think about the relative price across different items, right? So holding other things constant, all other things, the price remained the same, but only the X, right? Price of X came down, right? Then, compared to all other things, this particular item X has become cheaper than before, right? Say pizza is on sale this week, right? Then, compared to all other things, I mean Coke or whatever, hamburger or hot dogs, right? You have so many different choices to fill your stomach, right? But and let's say at the previous price level, you used to consume, let's say, 4 slices of pizza per week, right? But this week, pizza is cheaper. They are having a sale, right? Then, compared to all other things like hamburger or hot dog, pizza is relatively even cheaper than before, right? So that makes people to consume a little more of this particular good, right? That's the idea of substitution effect, right? Compared to all other things, this is relatively cheaper, so you're going to substitute this particular item, right? I mean, yeah. So if the price goes down, then the quantity demanded for X will increase as a result of substitution effect. If the price goes up, right, then the quantity demanded for X will decrease because X is now relatively more expensive, right, compared to other things than before, right? But income effect, there's an income effect, which means when the price of something goes down, right, then holding all other things constant, right? Let's say, okay, let's say every week you have $20 for your entertainment budget, right? And you know only two forms of entertainment, right? Movies and beers, right? And let's say the price of movie used to be $5 per piece, right? And per show, whatever, right? Price of beer is $2.50 per bottle, right? So let's say every week you used to watch 2 movies and what? 4 bottles of beer, right? That was your usual entertainment combination, right? But let's say this week movie theater is having a sale, right? So they lowered the price to $2.50, right? It only costs $2.50 to watch a movie, right? Then you can still drink 4 bottles of beer and watch two movies, right? And you still have what? $5 remaining, right? That's the idea of income effect, right? So when something becomes cheaper, price of X goes down, it's like you are having suddenly more money, right? Even though your actual salary or actual budget did not change, right? You simply have larger purchasing power, just like you have higher income or larger income, right? That's the idea of income effect, right? So when the price of X comes down, there is an income effect. Due to income effect, quantity demanded for X will increase, right? You will probably watch more movies because you have that $5 remaining, right? Even after consuming 4 bottles of beer and 2 movies, you still have $5 in your pocket, right? So you probably watch more movie because movie is a normal good. Yeah? Assumption is movie is a normal good, right? So when people have more income, they will buy more or they'll watch more movies, right? Okay, good. Well, of course, if the price goes up, then the due to income effect, right? Suppose this week they raised the price of movie to $7. Okay, then sorry, from $5 to $7. Then, after drinking 4 bottles of beer, you don't have enough money to watch 2 movies, right? You can only watch only 1 movie, right? So suddenly, even though you have same amount of budget, $20, right? You became relatively poor, right? Your purchasing power went down because of the higher price, right? So as a result, your quantity demanded for X will go down, right? So in the case of normal good, what we find out is substitution effect and income effect are on the same direction. They work on the same direction, towards the same direction, right? If the price goes down, both effects push the quantity demanded to what? Larger quantity or up, right? If the price goes up, both substitution effect and income effect have downward pressure on the quantity demanded. Okay? In the case of inferior good, the concept of inferior good is, of course, what? When people have more money, they buy what? Less of this particular product, right? And examples were what?
Mac and cheese.
Yeah. Macaroni and cheese dinner, ramen noodle, right? Or whatever. Yeah. Some usually low quality product, right? So when people have small amount of income, they consume a lot of this good, right? But when they have larger amount of income, right, then they will probably consume less of this low quality product, right? Okay? So here the substitution effect and the income effect. Okay? Substitution effect is still it still works the same way, right? If X becomes cheaper, right, it's still cheaper compared to other things, right? So people would like to consume more of that item because it's cheap, relatively cheaper compared to other things, right? Well, the income effect is different, right? If it's an inferior good, right? When the price comes down, that increases purchasing power of people. In other words, they feel a little bit wealthier, right? Even though their income remained the same, because price of this item became cheaper, right? They feel a little bit wealthier, which will make what? Their demand or quantity demanded for inferior goods lower. Remember, inferior good means when they have larger income, they consume less of this particular item, right? So quantity demanded for this item will go down because of income effect, right? If it's an inferior good, right? Okay. So on this side, we're going to have opposite. Right? If the price of something becomes higher, right, and that makes these people feel a little bit less wealthier, right? They feel, their budget is tighter, right? So in that case, they're going to consume more of this inferior good, right? So the quantity demanded goes up because of the income effect, right? So in the case of inferior good, we find out the substitution effect and income effect work in opposite direction, right? They sort of cancel each other, partly. Well, if in the case of inferior good, if the substitution effect was stronger than income effect, what are you going to see? What's going to happen to the quantity demanded for that item? Price of X went down, but let's say substitution effect was stronger than income effect, then total quantity demanded will increase, right? So price goes down, quantity demanded increase. That's what the law of demand says, right? The inverse or opposite direction, right? So we have price comes down, quantity demanded increases, right? So we still have downward sloping demand curve, right? However, if the income effect happens to be stronger than the substitution effect, what are you going to see? Then the actual quantity demanded will decrease, right? When the price goes down. And when the price goes up, quantity demanded will increase, right? What that means is the demand curve will be upward sloping, because when the price price goes up, quantity demanded also goes up, right? We call that given good. Given is a person's name, an economist who introduced this possibility, right? If for any inferior good, if the income effect is stronger than substitution effect, then actually we're going to see a upward sloping demand curve, which is violation of law of demand. Right? In reality, it is extremely difficult to find an example of given good. Almost none. Even ramen noodles, even macaroni and cheese dinner, right? If the price of those things goes down, quantity demanded will increase, even though they are an inferior good, right? The substitution effect is still stronger than the income effect, right? But the only typical example that they use is the potatoes, right? Demand for potatoes about 200 years ago in the United States, right? When the European immigrants were arriving to the United States, right? There's Irish immigrants, right? Their main staple was potatoes, right? And when the national economy, so initially as soon as they arrived, they consumed a lot of potatoes, right? But as the economy improves, right, and the national income increased, right, the consumption of potatoes actually went down, right? So that was the case of given good. No, that's it. What I just mentioned was just an example of inferior good, right? To be a given good, you have to look at the relationship between the price and quantity, right? So apparently at that time, over the many years, right, the price of potatoes went down, but the consumption of potato actually went down, right? That would be the example of given good, right? Here in this textbook, they use the example of this some region, poor region in China. Right? Some people, this was actually the case reported a few years ago. Yeah? They noticed that in this region, when the price of rice went down, quantity consumed for rice actually went down. Right? So we have a upward sloping demand curve for rice, right? And that was reported as an example of given good. Okay? Any question about this given good, substitution effect, income effect? Okay? Okay. The rest of the chapter is about the elasticity. Elasticity measures responsiveness of quantity demanded to a price change. Okay. Well, we already know about the law of demand, right? So at least we know about the direction, right? And for most of the cases, for all of the normal goods and for most of the inferior goods, right? If the price goes down, then the quantity demanded will increase, right? We know at least the direction of changes, right? But then what also matters is by how much, right? When the price goes down, when something becomes cheaper, right? How strongly do consumers react, right? what matters. Okay? That is a very important concept. Okay. So the what we call elasticity of or price elasticity of demand is a measure of responsiveness of quantity demanded to a price change. Right? And here's a conceptual formula. Right? Price elasticity of demand. We use epsilon, Greek letter epsilon, to represent the price elasticity of demand. Right? Is a percentage change in quantity demanded divided by percentage change in price. Okay? Well, we'll talk about actual calculation in a few minutes, right? But let's first try to understand how to interpret, right, these numbers, let's say. So elasticity is percentage change in quantity demanded over percentage change in price. Okay? And let's say after the calculation, this came out to be, say, 2. Actually, negative 2. Okay? If you calculate the price elasticity of demand, you will always get a negative number. Why? Why will you always get negative number?
Because the demand curve has negative sign.
That's right. Yeah, because if the price goes up, in other words, if this change is positive, this change will be negative, right? If price goes down, if the denominator is negative, then the numerator will be positive, right? By the law of demand, right? So you will always get negative. If you got any positive number, there's something wrong. Your calculation went wrong, right? Okay? All right, so you got, say, negative 2. What's the story here? What does that mean?
Changing price will result in much more changing.
Much more? Exactly how much more?
Twice.
Twice as you, right? So if the price goes up by 1%, what's going to happen?
2%.
Huh?
2% change in quantity.
Just change? If the price goes up by 1%, quantity,
2% decrease.
right, quantity demanded will decrease by 2% exactly, right? That's what this 2 tells us. If the price decreases by 10%, right? What does that tell us? If the price goes down by 10%, quantity demanded will increase by 20%, right? That's what this tells us, right? So this once, if you know the price elasticity of demand, it becomes very handy, very convenient, right? You will see, right, where we can use this. Actually, it is used to calculate the change in total revenue, total sales revenue, right? And based on that, you can determine whether you're going to increase the price or decrease the price, and by how much, right, and so on, right? It's a very important concept in pricing decision, right? How much you're going to charge for your product, right? All right. So if after the calculation, the absolute value of elasticity comes out to be greater than 1, like this case, right? Absolute value of this will be 2, right? Which is greater than 1, right? Then we say this demand is elastic. You know the concept of elasticity, right? If you bounce a ball, right? If the ball is elastic, it's going to bounce a lot, like, say, golf ball, right? If you drop the golf ball on a hard surface, it's going to bounce a lot, right? But if you drop, say, billiard ball, right? Billiard ball on the surface, right? I don't think it'll bounce a lot, right? Is that right? No, is it going to bounce a lot? No, not as much as golf ball, right? So in that case, we say a golf ball is more elastic, right, than the billiard ball, right? So, yeah, okay. So that's the idea: how responsive people are or consumers are to the price change, right? Well, if comes out to be 0.7, for example, if the elasticity comes out to be 0.7 instead of 2, which is less than 1, right? What does that mean? That means if you reduce the price by, say, 10%, suppose you had sale on your product in your store, right? Why would you have a sale on your store? What would be the goal or objective of having a sale? Charging less price, less for your product?
To remove the
Unsold. Okay. Inventory. Okay. Well, maybe, yeah. But there is a more important, more popular reason for having a sale. Okay? What do you expect if you put up a sale sign on your store? Increase, first of all, sales, right? You would expect more people to come to the store, right? If you have a sale, right? And that means you would expect to sell more. The quantity sold, right, would increase, right? So, yeah, if you cut the price, then according to the law of demand, yes, your quantity demanded will increase, right? Unless it's a given good, right? But important thing is by how much, right? If the elasticity was only 0.7, less than 1, right? That means if you cut the price by 10%, by how much your quantity demanded will increase? 7%, right? It's only 7%. What's going to happen to your total revenue, total sales revenue, right? Your total revenue is P times Q, right? How much you charge per each unit multiplied by how many units you sold, right? So let's say it used to be $10, right? And you used to sell 1,000 units per day or per month, whatever, right? So your total sales revenue, monthly sales revenue used to be, say, $10,000, right? Now, suppose you have 10% sale, right? So price goes down to $9, right? But you found out that the price elasticity of demand for your product was only 0.7, right? What does that mean? Your sales will increase by only 7%, right? If you cut the price by 10%, right? So that's going to be what? 1,070, right? Sales increases by only 7%, right? What's going to be? 9,630. Is that right? Huh? So, was it a good decision to have the sales? Yeah? No. The idea of sale is to increase your sales revenue, right? Selling more is good, right? But if people are not very responsive to the elasticity, not responsive to the price change. In other words, if the demand is inelastic, right? then when you reduce the price, your total sales revenue will actually go down, right? In this situation, in other words, if you know your product is inelastic, I mean, if the demand for your product is inelastic, what should you do? Yes, you have to increase your price, right? If you want to have larger sales revenue, you have to charge more. And if you charge more, what's going to happen to the quantity demanded? It will go down, no question about it, because the law of demand. If the price goes up, quantity demanded will go down, unless it's a given good, right? But not as much as your price increase, right? So in that case, if you suppose you raise the price by 10%, right? So you charge $11 per unit, right? Then the quantity demanded will decrease, but only by 7%, right? So your sales will go down to what, 930? Yeah, 930, right? So 11 times 930 will be what? 1,002, what, 1,020 something, is that right? 1,020 exactly? No? Oh, sorry. Oh, 10,000, yeah, sorry. 10,000, what is it? Come on, calculate it. 10,230? Good. 10,230. Good. Yeah. So, by increasing your price, you can actually increase your sales revenue, right? Because people are not very responsive to price change. Okay? That's the idea, right? So knowing the elasticity, price elasticity of demand is very important in your business decision. Yeah, how much price you're going to charge, right? Okay. So how do we actually calculate the price elasticity? Okay. All right. Well, the general formula for the percentage change, calculating percentage change, is what? Well, percentage change is a new number minus old number divided by old number times what? You did this in your chapter 1 appendix exercise, right? In the My Econ lab. How do you calculate the percentage change, right? Times what? 100, yeah. Okay? So suppose you got some raise in your salary, right? And you want to find out exactly what percentage increase your salary had, right? Then you're going to be new salary minus old salary divided by old salary, because that's the starting point, right? Times 100, right? If you want to find out, say, economic growth, what was the economic growth rate, right? Then the GDP of this year minus GDP of last year divided by GDP of last year, right? Then you're going to get the economic growth rate, right? Inflation rate, right? Price level of this year minus price level of last year divided by price level of last year, right? Yeah, so, you know, whatever you want to calculate percentage, right? So here, it's going to be, okay, so we have, let's say, here's P1, Q1, and let's say P2, Q2, right? So percentage change in quantity would be what? Suppose price goes down from P1 to P2, right? Then it's going to be Q2 minus Q1 divided by Q1, well, of course, 100, right? And P2 minus P1 minus P divided by P1 times 100, right? So, they cancel out each other, right? So what? We end up with this, right? That's the formula for calculation formula. Okay. Okay. Cool. All right. So here, what if price changed from $3.50 to $3.30? Can you calculate the elasticity? Right. So it was $3.50, $3.30, and this was 2,000, 2,500. So according to the formula, well, it's 2,500 minus 2,000 divided by 2,000 over 330 minus 350 over 350. Yeah. If you do that, you're going to get negative, what was it? 375, negative 4.375. Someone interpret this number. What does that tell us? What's the story?
Consumers are really responsive.
Very responsive, okay, very elastic. Exactly how much? How elastic is the demand? If you lower the price by 1%, you can expect the quantity demanded to increase by 4.375% exactly, right? That's what tells us. Right? But here, suppose you went back up. Suppose from $3.30 you raise the price to $3.50, right? Then what are we going to have? We're going to have 2,000 minus 2,500 divided by 2,500 over 350 minus 330 over 330, right? If you calculate that, you're going to get exactly negative 3.33. Okay? Well, we've got a problem here. Yeah? The problem is on the same demand curve, right? And over the same price range, right? Depending on whether you lower the price or raise the price, we get completely different answer, right? For demand elasticity, which doesn't make sense. Because usually, in reality, in real situation, right now, you are at one point, right? You are at one point on the demand curve, whatever, right? And you want to find out what's going to happen to your sales revenue if you raise the price or lower the price. And if you get completely different answer, right? That's a problem. Right? What should you do? Right? Well, in reality, we don't have that problem because we calculate a point elasticity, which means we're going to calculate the elasticity at one point. And how do you calculate the elasticity at one point? I mean, you have to have this percentage change in quantity and percentage in price, right? If you're at one point, there's no change, right? Well, you can use calculus, right? Change in price approaches zero, right? And you can use this formula, right? Okay, so in reality, there's no problem. You can use you can calculate the elasticity at one point, right? At current price level, right? We have this problem only because in this class, we are trying not to use calculus. Okay? In the introductory economics, right? There's an unwritten rule that we are not going to use calculus, right? So instead of point elasticity, we are calculating arc elasticity. Arc elasticity means we're calculating the elasticity over this segment, over a certain range, right? Then, whether you use this one as the starting point or this one as the starting point, we get completely different answer. Okay? So in order to avoid that problem, we just decide that we're going to use a midpoint, right? Instead of A or B, we're going to just use the midpoint as the starting point. Whether you're going down or up, doesn't matter, right? We'll just assume that we have started from the midpoint, right? Then you're going to get the same answer, right? Whether you go up or down, right? So that's the case of midpoint formula, and we're going to continue this on Thursday. Any question? Okay, I'll see you on Thursday.